This is a tough question. If you're able to answer this, means you have a really good hold on the concept. So please pause and have a try. Give it a try. Okay, let me start with giving you guys a clue. First, we'll name the resistors. This is R1 because I1 is over here. It is more convenient. R2, R3. Next, let's name the node A, B. Oh, there's one more over here. C and D. Okay, let me actually. This is more convenient. A, B, C, D. Right. So these are your important nodes. Actually, the only nodes. Then what else? I want to give a clue regarding voltage across A and C. Figure out the voltage across AC. You'll be able to, that's the tough part. Try to figure out the voltage across A and C. That's your first clue. Okay. Your second clue will be how to figure out VAB. That is VAC, sorry. See, we have the current through this. Right? I hope you guys have read the question. The current through 8 ohm is 0.4 ampere. So we know the current through this part of the path of the circuit. So I'll rewrite the figure for you guys. Only that part. V, this is B and C. So we know the current through this, that is 0.4 ampere. We know the resistance. We have to figure out the voltage. It's not that hard. Please try. Okay. So if you're not able to find it, pause this. Let me explain. So first thing first, I'm not going to write the given. Too many things. I'll directly start with the working. So I would like to make a general statement regarding the current through both of this. As 8 ohm and 22 ohm are in series. Actually, I could have written R1, R2 and R3 anyways. Thus, 0.4 ampere current flows through both. Yeah, so that you guys recall the concept. You need not write this, by the way. I just wrote it for sake of understanding. Next is we have to figure out VAC. By Ohm's law, you can tell that VAC is equal to current I2, we'll call this as I2, into combination of R2 and R3. So this is your effective resistance of R2 and R3. So we know I2, that is 0.4. We know R2, R3, that is R2 plus R3. So this is 0.4 into 8 plus 22. So this is 30, that is 12 volt. Okay, this is the effective resistance is 30 across AC. I mean, not exactly AC, but this length. And the current we know, we found the voltage. Now can you figure out I1 and then figure out I and then figure out the voltage through this or the current through this and the voltage across 22 ohm and also X. Again, okay, let me put it slow. Next is we can find I1. I given in weird sequence so as to confuse you guys. Next is we can find I1 with this information. So again, VAB, the voltage across VAB is equal to I1 into R1. This is 12. I1 we need to find. R1 is 15. So best thing to do is divide with 15 both the sides. Cancellation. So both is divisible by 3 4s are 5s are 0.8 is equal to I1. so many ampere. So now we found I1 0.8 ampere, and this is already known. Can we figure out I? It's not that hard. So simple. Total current, circuit current I is equal to I1 plus I2. So this is 0.4 plus 0.8, which is 1.2 ampere. So this is your total current in the circuit. Now, what is the current through 5 ohm? See, the idea is same current will go through, is it not? That's the whole idea of a circuit, right? That's why you're able to do so much. So obviously the current through 5 ohm is also 1.2 ampere. So we can tell current through 5 ohm resistor is 1.2 ampere. Next, what else? Lot of things to do. Voltage across 22. I could have found it here only. Anyways, so we know the current through 22. We know the resistance of obviously 22 ohm, and we can find the voltage. So voltage across 22 ohm is current through 22 ohm into resistance of 22 ohm. That is 22 ohm. That is R3 if I remember right. So this is 0.4 into 22. So 8.8 volts. Okay. Now the last one, the voltage of the circuit, right? X we have to find. Okay, so we can do it in two ways. Find the effective resistance and then do it. If not, we can use conceptual idea that VAC, the voltage across AC, is 12 volt. We can find the voltage across 5 ohm, add it up, and we'll get this. I'll explain it below. So what I'm trying to tell is this. I have two set of resistance connected to my voltage. Yes, this is parallel and this is more complicated, but end of it, it's also in series. This is in series with that. That's all we need to know. This is my VC if I remember right. And this is again C, and this is my D if I'm right. Right, this is C and this is D. Yeah. So this we already found. VAC we already found. We need to find VCD. VCD is nothing but current through 5 ohm. We know the current, not current, voltage across 5 ohm. We know the resistance. We know the current. We can find VCD. So VCD is equal to I into resistance 4 if I'm right. I not named it actually. Anyways, 1.2 into 5, that is 6 volt. So this is 6 volt. This is 12 volt, right? So this is 6. This is 6. This is 12. You can find X. X is equal to VAC plus VCD. This is the idea behind series connection. Whenever you have series connected resistance, the current within through them will be same, and the voltage will be such that the sum of it will be equal to the voltage at the ends. And at the ends, we have a connection directly to the battery. So that's what we want to find. So this is 12. This is 6. So this is 18 volt. Right? So now pause and have a look at the answer. I feel like explaining once more. I'll just do it off. So let me. See, we have a current that is given through this. So I can find the voltage between this end. And also the voltage across this and the voltage across this if I want to. And one of it, it's asked. Okay, I found the voltage across this end. So thus I can find the voltage across this also. Since I know the voltage, right, I can find the current, and I already know this current. So I can find the total current. So the same current will go through 5 ohm as well. Since I know the current between this end and this end, right, I can find the total voltage supply to the circuit by just adding the voltage across this end and this end. As simple as this. This much of explanation will cover pretty much all of this problem and pretty much every problem that you will be doing in this chapter. Okay, so please watch the video again if you guys want to. But yes, this is required that you will understand every point in this particular question.